Hello everybody. Today we are solving a probability question that involves doing tests on 100 people for a disease and using two methods to do that. So the first method involves like doing each test one by one. So since there's 100 people, we would need to do like 100 tests for everybody. And the second method involves dividing 100 people into 10 groups with 10 people in each group and then mixing like their blood into a pool and then testing that mixture. And if that mixture turns out to be positive, then we do like 10 more tests on each individual. So in case that the pool turns out to be positive, we would need to do 11 tests. And if it's negative, then we just need to do one test. So you can see that this is clearly the more efficient method to do this. But what we need to find out is what is the average number of tests we need to do using the second method and how better is it from compared to the first method. So if you see, let's just think of one group at a time and let's like try to approach the problem from that perspective. So suppose we have one group and if there's one group, then if that group tests positive, then we need to just do only one test. And if the group tests negative, then we need to do like 11 tests uh, for them. So we need to find, let's just assume that K is the average number of tests we need to do for a group. So what would K be? So like K would be something like probability of doing one test and doing it one time. So probability of one test. And probability of doing 11 tests, like multiplying it by 11 times. Does that make sense? Like we are trying like on average how much, like how many times, like if K is the average number of times. So if K is the average number of times, then like average number of times we need to measure it. Measure it like what test. So P of one test would be 11 tests, right? That makes sense. If this is clear to you, then solution should be like fairly straightforward. It comes out to be, so what is probability of just doing one test? So that would mean that everybody in the group is negative. So the probability that everybody in the group is negative would be 1 minus 0.1, that everybody in the group is positive, like the probability that everybody in the group is positive, into like doing that 10 times. So that would be like 1 minus 0.1 raised to 10 and then multiplied by 1. So yeah, plus the probability of doing the test 11 times would be so like probability of doing one test plus probability of doing 11 tests should be 1. So probability of doing 11 tests would be 1 minus probability of doing one test, which is 1 minus 0.1 raised to 10. This does not look very clear, but once I solve this should like look a lot clear. This becomes 0.9 and this becomes 0.9 as well. Now you can see that it's much more clearer. And this becomes so I'll just do the calculations on the calculator, and this comes out to be somewhere around 7.5132. So, like, this is the average number of tests that we need to do for. So, since we have 10 groups, so the average number of tests that we need to do for this would be like 10K. I mean 10 into K, not 10,000. But 10K, which would be 10.7 point into 7.5132. So that's around 25. So we can write 75 or we can write 76. We can write 76 actually. So on average, we would need to do 76 tests using the second method for testing 100 people. So we would be saving around, like we would be doing around 24 tests less compared to the first method. But it's still a lot more tests. We can use something like a binary search method. I mean, yeah, it totally depends. Not a binary search method, but yeah, there should be like more efficient methods. Yeah. 24 less tests needs to be done. I hope this problem was clear. Uh, Thank you for watching.